hey gang, let's look at filtering a little bit more in depth with regard to how it operates in the context of EIGRP. And what I want to do is what we did in our RIP conversations. And that is I want us to start using the topology that we have right here in order to be able to create scenarios where we can do traffic shaping using filtration. Now, let's look at this. I could set it up for a number of different scenarios. Scenario 1 is going to be that I do not want to learn any odd prefixes. So no odd prefixes. Now we need some prefixes to play with, and I don't think that we have quite enough in this scenario. So let's go over to R1 and create some. So let's take a look and see what we got here. So show IP interface brief, E assigned. Oh, nope, we already got some. So I've got 8 of these bad bears. So 100 through 107. Let's see if they're showing up, which they should. So trace route to 11, 11, 0, 11. And we're load sharing across R2 and R3. So let's just pick the bottom one. Let's say 7, 11. And we're load sharing there. So we do have the prefixes already configured. Now here's the situation. I only want to learn prefixes that are going to be even. So no odds. So that means I need to learn even prefixes. So let's take a look at exactly how we would do this. And we're going to do it with regard to our basic configuration on R22 in the data center. So what we'll do is this, config T, and I'm going to say, I need to create an access list. Do show access dash list. Let's see if I've got one. No, I don't. I'm going to say access list 1. So I'm going to use a standard access list, and I'm going to say permit, and I want to learn no odd, which means I need to permit the evens. So if I go through and say, I don't care what any of these values are, but it can be anything in the first octet. Keep in mind, let's just illustrate something here. We're using a wildcard mask. So 0 means it has to match, and 255 means it can be anything. So I don't care about the first octet. So I'm going to say here that it can be 255. I don't care about the second octet. It can be 255. Now the third octet is where I want to make certain that I use this idea of even and odd. Now when I look at this, what I'm going to recognize here is that means that I'm going to have 1 bit turned on in order to represent or count evens. So I'm going to start at 0. As you can see, I've got the 0 here. And I'm going to have to go 0, 1, 2, 3, 4, 5, 6. Now remember, we talked about how we did that type of counting. If I use, say for instance, a 2 or a 2 here, that means it's just going to take the first 3 prefixes and it's going to allow me to manipulate those. I need to say 254. So what I'm going to do is I'm going to take 256, subtract 2 from it, I'm going to get 254, and that means this is always going to be an even value. Now, when I look at this, I also need to know or pay attention to the fact that I don't care what's in the 4th octet. So I'm going to say 255. And then I'll hit enter. Now with that accomplished, I need to apply this filter. Where do I apply the filter? Well, I'm going to apply the filter under the router configuration, router EIGRP 10, using my old buddy, the distribute list. Now the distribute list is going to say I need to specify the access list that I want to use. So let's say access list 1. And what I'm going to say is I'm going to say in, but I'm not going to specify an interface. I want this to happen based on any source I'm learning a prefix from. So whether it's R2 or whether it's R3, I only want to learn the evens. So I'm not going to use this idea of the interface. So let's see, it should clear my connection. Clear IP EIGRP neighbors. Oh, cleared it anyway. I'm always so impatient. I apologize for that. It's difficult for me to just sit here and wait. Now let's take a look at our routing table. Show IP route. Now if I look at this, let's look at my 11s here. So do I have any prefixes that are odds? So the question here is, can I ping any of my odds in my 3rd octet? So if I ping 11, 11, 1, 11, can I reach it? Nope. Can I ping 7, for instance? We'll see. I'm going to change my repeat count here. I'm just going to have it repeat for 2. So can I ping 7, 11, repeat 2? Can I ping 6? Sure can. And that I can see show IP route EIGRP 1100. What am I doing? Show IP route. And I'm going to load balance. So if I do trace route to 11.11.0.11, I'm going to load share. But the thing is I'm now pointedly saying I don't want to learn any prefixes from any device into my routing process on R22 if it's an odd prefix. Now, let's modify this. Let's create a new scenario. So scenario 2. Learning scenario 2 is going to be that I want to learn my evens from R2, and I want to learn my odds from R3. All right, with that being said, what we need to do is see what goes into this process. Well, that means that on the connection to R2, I need to use 0, 0, 0, 0. And again, I'm going to say first octet doesn't matter, second octet doesn't matter, 254. The third octet, the only thing that matters is going to be values of 2 and 255. Now on the other device, probably should have done these in different colors, sorry. It's going to be 255, 255, 254, 255, but the problem is this third octet is going to start with a 1. So let's see what goes into this. So first of all, on R2, I'm going to get rid of my access list. Config T, no, access list 1. Do show run section router. I'm going to get rid of my distribute list. Router, EIGRP 10, no, and get rid of that. So now what I want to do is create my access list. So I'm going to use 1 for my odds. So that's going to be, like I said, access list 1 permit 0, 0, 0, 0, 255, 255. Actually, this is going to be my odds, so it needs to start at 1. 254, 255. Let's go ahead and create access list 2. Only we're going to start our counting at 0. Now what we're going to do is we're going to go under our routing process, router EIGRP 10, and I'm going to say distribute list 2. What I want to do is I'm going to say that I want to do that inbound, and I want to do it on serial 2/0. I'll repeat the same configuration here, only I'm going to say 1, I want to process it on inbound on serial 2/1. Now this should force my process to reset. We'll just wait for it. So the neighbor changed to 2. Let's see if the neighbor changes to R3. There it goes. See configuration change. I'll take myself off the equation. Notice it says interface configuration change. It's a resynchronization. So let's take a look at our routing table. Show IP route EIGRP. And what we want to do is get down to the 11s. Notice we have a single entry. 0 we're learning from R2. 1 we're learning from R3. 2 we're learning from R2. 3 we're learning from R3. 4 from R2. 5 from 3. 6, which is even, we're learning it from 2. 7, which is odd, we're learning it from 3. So we've accomplished what we opted to accomplish. So let's do a trace route. So let's say trace route to 11.11.0.11, and we should find that we're going to go through R2. If I do a trace route through R3, or for the first odd, we should go through R3. And that's what we see. Evens going through R2, odds are going through R3. So let's just pick another one. Let's say 7 should go through R3, which we see it is. And then lastly, 6 should go through R2. So pretty straightforward with regard to how things are configured. And I want to make absolutely certain that we understand the nuances of this. Remember, we can do it against the process, the EIGRP process itself, or we can do it selectively for the EIGRP process based on the device or the interface that we're learning our prefixes from. I could have just as easily gone to R2 and said, do not advertise anything but the evens or the odds out the particular interfaces to accomplish the same config, but that's not going to be something I'm going to focus on. Right now, I've demonstrated how we can use standard access lists to perform filtration. Now, what we want to do is look at the idea of using extended access lists to do filtration. And again, since it's extended, remember we have source and destination values that again makes our command syntax much more granular with regard to what we can accomplish in a single filtering operation. So with that said, I'll see you guys in the next video. Bye-bye.